So, when people operate with draw pictures like this, the implication is that you need to work with single supply, with dual supply, right. If you want to work with single supply, all right, what do you need to do? Well, everything that is ground in this circuit, okay, must be connected to VDD by 2, and this becomes ground, this becomes whatever VDD, all right, and this is the input must be riding on VDD by 2 plus V in, and this is say R, and that is R, and the output will be VDD by 2 plus V2 by 2 minus V. Okay. So, this VDD by 2 VDD by 2 is often called the analog ground. Okay. Just like how, when we had dual supply operation, the middle of the supply range was ground, correct. Now, this is this VDD by 2 is playing the middle of the role of the middle of the supply rail, because half of the positive rail plus half of the negative rail is VDD by 2. Is that clear? All right. Now, this poses in some situations this may pose a bit of a problem, right, in the sense that the often it so happens that often the input source, for example, Vi here, one end of the source is grounded. We do not have access to that terminal. We only have access to the to this terminal. Okay. So, when Vi is 0, this voltage is actually 0 volts. Okay, but now your op amp amplifier, for instance, here, or even let me take another example. This is let us say this is a non-inverting amplifier operating with single supply. What should the node voltage be connected to? Okay, let's connect this to ground, and let us say we are operating this at single supply. So, this is VDD and this is ground. All right. Now, if I directly connect this to this, so this is R and this is R, so we are expecting a gain of 2. So, what will happen? What comment can you make about the common mode voltage at the input of the op amp? Yeah, if Vi is 0, there is no input signal, or the input signal is so small. What is the common mode at the input of the op amp? 0. Okay. So, what does this mean? Will that be in the common mode range of the op amp? It won't be in the common mode range of the op amp. Okay. So, so first thing we need to do is we need to push the common mode up to VDD by 2, all right. And what should and that is one thing, and what should be if you had dual supplies, then this was ground. Now we have a single supply, so what should this be? Remember, this should be VDD by 2. All right. Does that make sense? Okay, but we have a real problem here on the input side, because our input, let us say this is some input source which is perhaps has got some source resistance Rs. Okay. We do not have access to the other terminal, and this voltage, what voltage should we put there? We can't connect Vi there directly. It has to ride on, this should be this is only Vi, this should be what we want here is 10 volts or VDD by 2 plus Vi. Okay. So, what do you think we could do? Connect a voltage source in series. Ideally, in principle, what we want to do is connect a voltage source in series of value VDD by 2. All right. We'll see how we can get this voltage source in a little bit, right. But if that is the case, this is VDD by 2 plus Vi, and what is the output voltage? This is VDD by 2 plus 2 times Vi. So, basically it is exactly like the ideal circuits that we saw, except that whatever was ground is now VDD by 2, because we are working with a single supply. Does it make sense? Okay. Now, the same the problem with only one terminal being available also occurs with respect to a load. In many cases, for example, I don't know, maybe you are driving a speaker, right. In most probability you do not have access to one terminal of the load, right. That is one thing. The other thing is that if I and this terminal is always connected to ground. Now, if I connect this to directly connect this to RL, correct. What comment can we make about the DC current even when Vi is 0? What comment can we make about the DC current flowing through RL? VDD by 2 by RL. So, it turns out that many loads also do not like DC current flowing through them, right. For example, your loudspeaker has got a has got a coil wound around a magnet, and if DC current flows through the loudspeaker's input terminals, then it is going to basically demagnetize the magnet. Okay. So, that is something that you do not want to do. So, therefore, if you want to make sure that no DC current flows through RL, what comment what can we do? Now, why is there DC current flowing through RL? That is because this potential is 0. Assume Vi is 0. So, on the left side it is VDD by 2, on the right side it is 0. So, when you join the two, obviously current will flow from DC current will flow from left to right. All right. So, in principle, if you want to prevent any current from flowing when you connect the load to the output of the amplifier, what should we do? In principle, you must put a battery of value VDD by 2. Correct. So, this way the output voltage will be 0, right. When Vi is 0, the output voltage will be 0 and there is going to be no DC current flowing through RL. Does it make sense? Okay. Now, the question is how do we make a, where do we get a battery from with with a voltage VDD by 2, all right. And to see that, let me ask you a leading question. Suppose I gave you 2 boxes, 2 black boxes. One contained a battery, inside there was a battery of voltage 1 volt. In the other box there was a capacitor of voltage 1 volt. Okay. And now I am asking you, you only have access to the terminals at the edge of the box. I am asking you, in which box is there the 1 volt battery and in which box is there the capacitor. How will we figure this out? Pardon? Okay, you connect a resistor, the answer is okay. Let us try and connect a resistor R, okay, to both boxes. What happens? Very good. So, basically if you have the box in which, if you take a resistor and connect it across the 2 terminals, in the box in which there is a battery, the voltage across the resistor will remain at 1 volt and will remain constant, it will not change with time, all right. Whereas, the output of the the other box will be 1 volt times e to the minus t by RC. Is that clear? Okay. Now, if I make and why is the voltage reducing? Well, this resistor is removing some charge from the capacitor, and because the charge from the capacitor, the voltage across the capacitor is the charge divided by capacitance. So, if the charge is going on leaking away, then obviously the voltage across the capacitor is decreasing. Now, what if I tell you that the capacitor inside is infinite? It will maintain the constant voltage. So, basically if the capacitance inside was infinite, right, you are removing only a finite amount of charge, but there is infinite amount of charge inside the capacitor. So, the change in voltage across the terminals of the capacitor basically will be, it will not change at all, right, or it will change so slowly that you will not be able to figure it out. In other words, the time constant, RC time constant is infinite. So, for all practical purposes, so it therefore remains constant, that is what it means. Is that clear? So, what is the moral of the story? An infinite capacitor charged to a voltage Vx is indistinguishable from a battery of voltage Vx. Does it make sense? All right. So, so if we want, for example, so for example, here using this, if I replace this by an infinite capacitor, what comment can you make about the what comment can you make about the voltage across this capacitor? Because why this voltage is VDD, when the input is 0, this voltage is VDD by 2, the left plate is at VDD by 2, the right plate is at 0. So, initially when you turn on the circuit, this capacitor will get charged to a voltage VDD by 2, right, and this is an infinite capacitor. So, therefore, it will hold that voltage, I mean it is indistinguishable from a battery, and therefore, basically the output there will be 0, the voltage across this infinite capacitor is VDD by 2. So, basically the output voltage is, when V in is 0, the output voltage is 0, and so what is this voltage? The left side is VDD by 2 plus 2 Vi, this will simply be 2 Vi. Okay, and if Vi is AC, there is no DC current flowing through RL. Does that make sense? All right. Likewise, now on the left side, what do we do? What do? We need the battery of VDD by 2. What do we do? Replace it, okay. The suggestion is replace it with an infinite capacitor. Let us do that. All right. Now what? What is the voltage? I mean, what is the voltage across the capacitor? On the left plate, it is left plate 0. Right plate? No, we don't know. What is it? It is floating, right? So, we want, what do we want across the right plate voltage to be? VDD by 2. So, what should we do? We take a potential divider, Rx, VDD. So, when you power on the circuit, the right plate will be settled at VDD by 2 and the left plate at 0. So, the voltage across this capacitor will be VDD by 2. So, does it make sense? So, what is the absolute, what is the total voltage there? VDD by 2 plus Vi, is that correct? Think carefully. Because Rx, right. So, let us take a careful look at so this is Vi, Rs is the infinite capacitor, this is Rx, this is Rx, this is VD. So, what is this voltage? How many sources are there? 2 sources, and I mean let's call this C equal to infinity, right, and then we can replace C with infinity later. So, this is a linear network with 2 inputs. So, we can use superposition. Okay. So, if only VDD was present and Vi was 0, what will this voltage be? It will be VDD by 2. Okay. If VDD was 0 and only Vi was there, what will be the voltage here? Plus, what is the transfer function from Vi to the output voltage? So, VDD is 0. So, basically the 2 Rx, we set Rx VDD to 0. Rx, this is C, all right, and this is Vi, this is Rs. Correct. So, what is so Rx and Rx become Rx by 2 in parallel, and the 2 in parallel become Rx by 2. So, what is this voltage? Just use the transfer function is Rx by 2 divided by Rx by 2 plus 1 by S. So, if C becomes infinite, infinite C implies VO by Vi is nothing but Rx by 2 divided by Rx by 2 plus Rs. So, how will we choose Rx therefore? So, this basically is C is infinity, this is nothing but Vi times Rx by 2 divided by Rx by 2 plus Rs. So, if we want this factor to be close to 1, what should we do? Rx by 2 must be much larger than Rs. If this is true, then Vi times Rx by 2 divided by Rx by 2 plus Rs is approximately equal to is equal to Vi. Does it make sense? So, these capacitors are often called coupling capacitors. Right, and if they are, I mean, as we saw, if they are infinite, then they will simply behave like batteries, all right. But I mean, of course, on paper we can say capacitance is infinite, but in practice, you can't bring an infinite capacitor. The only thing you can do is, well, you instead of putting an infinite capacitor, you put a large capacitor. Now, the question is, what is the meaning of large, right?